For our friends that need it recorded. Okay. Hopefully, yep, it'll recenter. Okay. So we're doing p.1. Oh, I hope you guys had good weekends. How are we feeling? Good? Yeah? Tired? Good? Anyone have a hard time waking up this morning?
I drove 6 hours straight yesterday, so.
Wow. So we're all tired. Max, what'd you say?
My 2 dogs ran away.
Oh, no.
No, they're fine.
Oh, God.
Diligent is like run away. She was just laying the big
Okay. So busy morning already. Okay. We're gonna go through this pretty quickly, but I'm also going to remember that you've probably not looked at geometry for like a couple months, or sorry, you haven't looked at any math in a few months. That's probably true, correct? Okay. If I'm moving too slow, let me know. If I'm going too fast, also let me know. We're gonna start with actually some like long division. So welcome back to like the 4th grade where we did some long division. We need to find the decimal for these points. So we're gonna set up like a long division. The number on bottom goes on the outside, and the number on top goes on the inside. The negative can go wherever you want. I just know that my final answer will have a negative in it. Throw some zeros and a decimal attached to the end, so you have somewhere to go. I ask myself, okay, how many times does 8 go into 7? It doesn't. So then I move over a space and I say, okay, how many times does 8 go into 70? Anyone have any thoughts? 8. Very good. 8 times 8 is 64. Minus it off, and I'm left with 6, right? Carry my 0. 8 goes into 60 how many times? 7. Very good. That becomes 56. Minus it off, and I've got 4. Oh, I need one more 0 to carry down.
5.
I made it. Okay, 5. Perfect. So the decimal version of negative 7/8 is negative 0.875. All right. Let's do one more together. I've got 5 divided out of 13. This one's nice because we do have a whole number at the beginning. So I know 5 goes into 13 2 times. That one's easy. Minus it out. Carry down to 0. Oh, nice. This was even less steps because now 5 goes into 36 times. So my final answer is 2.6. Okay. Can you do one more like that?
Yeah. Yes.
Perfect. Go for it. What do we get? Say again, Ava. Good. Where is the repeating? What does that mean?
Because it keeps going like this. When you subtract 18 from 20, and then you keep getting the same answer, so it's just keeps going on 2.
Forever and forever, we're always going to get 2. It's not going to be simple, so we know that the pattern's going to continue. We just throw a repeating bar on top. Cool. Okay. Question: does anyone remember what we call these kind of numbers? Numbers that can be written as a fraction. That is an improper fraction, but like what's the big general?
Real. Rational.
It is real. I like rational best. Rational is the most specific number. We're gonna draw a little number line. I know that we do this like on the first day of like algebra 1, maybe even algebra 2. I'm gonna draw a box that shows how all of the numbers relate. So we know real is the biggest category. So I'm gonna put real on the outside. The next biggest category is rational. And we use a fancy Q to represent that. So it's like a Q with an extra line through it. So Q, but it's got like a line through it. And I'm gonna write rational next to it if I've never seen that before. If a number is not rational but is real, do you know what kind of number that is? Irrational. Irrational numbers. And that's an I, like a fancy I is irrational. Can you give me an example of an irrational number?
Pi.
No, 11 over 9 is rational. Ava? Pi. What's another one? Ava, another one?
Like square root of negative 5.
No.
Square root of 5.
Square root of 5 works.
I was thinking of imaginary, sorry.
Imaginary numbers. While we're thinking of them, we can draw them. Do they go in my box that is all my reals? No, they're imaginary. They come over here. I make them a little cloud because I believe imaginary numbers are like a little cloud. A little I. Bless you.
And what did you put in the imaginary?
I just put an I.
Like what number?
Oh, like number like negative, Ava said root of -5. So if you have a negative under the radical, that's an imaginary number. Okay. Michael did give me a good example of rational. So like 11/9 is a good example of a rational number. So any number that can be written as a fraction. There's 3 more categories inside rational though. The next biggest category under rational is, nope, one more before that. Negative numbers. Very good. What do we call negative numbers? Integers. Wow, you guys are so much better than A period. They really struggled, or Alpha, they really struggled with this the other
We
day.
had like a chart of it last year. Ms. Glenn gave us one.
Oh, nice. Okay, so the misleading to class, got it. So integers are any positive or negative numbers. So I'll write like -3 counts as an integer.
Is that a Z?
A Z, a fancy Z. You will probably not do a lot with these sets. I like to show them. When I did a math major in college, I took classes that were all just like, we use these letters all the time. So I like to show them to you guys in case you ever see them again. Underneath integers, we have whole numbers. Somebody already told me that, right?
It's like
Whole, like a fancy, it's like a fancy W, and it is zeros and all my normal counting numbers. And what do we call the counting numbers? Eva?
natural numbers.
Natural numbers. Very good. And I'll just make a little thing and I'll put an N.
Is natural the same as whole, just not 0?
Yes. Another way we call them is the counting number. So if I were like count how many students are in here, I'm not going to go 0, 1. I go 1, 2, 3. So we have to have a category for my natural numbers. So that's like 1, 2, 3, etc. So that being said, these were all rational numbers, and we're going to use the word rational. We're going to use the word real. I like to kind of remind you where all of those came from. Okay? Anybody have any questions yet? All right, let's keep rolling. Now we're going to graph on a number line, okay? We're going to do some interval notation, and we're going to do some inequality notation. So this first one says x is, how do I read that sign?
Greater than
Greater than or equal
Greater than or equal to -2. All I have to do is do a number line with my -2. I don't need any other numbers. Is that going to be an open or close on -2?
Close. The equal and or equal.
And which direction am I going to go?
To the right.
To the right for my greater than. Very good. I got one more to do with you like that. I've got 5 less than x, which is less than or equal to 6. What 2 numbers do I want on my number line? Good. Open or close on 5. Open or close on 6. Very good. And then where am I shading in here?
In between.
Towards each other.
Towards each other. This is always a little confusing to us because you're like, well, they're both less than. Yes, but when we read the first one, it says 5 is less than x. So that means I want any number bigger than 5. That number x is all the numbers bigger than 5. And then same thing, x is less than or equal to 6. So we're going the opposite direction. I think this is the easiest to shade because I just always go in between them. Okay, next we're getting into interval notation. Have we seen interval notation before? Give me a nod. Yes? Nice. Okay, the other 2 teachers are really helping me out. In the past, I had to like teach it to you guys, so it was a little bit harder. Let's remind ourselves some basics. So this is interval notation already. The first number is always what? The bigger or the smaller number?
Smaller.
Good. The small number is always, always first, and the second number is always the big number. On the outside of my interval notation, I can have one of 2 symbols. I can have a parentheses. What does that parentheses like imply? Not it goes on infinitely. Yeah, Billy? It's not on a point? Yes. We could use like an open circle to represent it because we don't get to actually include that point. The other thing I like to think of is it's just like not included in my answer. So like if I have a parentheses, like 5 is not an answer, but like everything up to 5 is an answer. Everything past 5 is an answer. The other symbol I could have is this. Yeah, Ava?
Oh, sorry. Never mind. I was gonna answer.
Oh, you're gonna answer the question? Give me a second to ask it. This is called a bracket. What does the bracket mean? Ava?
It means that it can be like a one point, so it would be like a closed circle. So like if something is like on it.
Good. It counts as a point. I close circle. I say included. It is included. Oop, I ran out of space. Pretend that says included. Included. Okay, so now we're gonna graph these. So same idea, we're gonna do a number line. My question is, this says negative infinity to 5. Can I go to my graph and put like negative infinity somewhere? No, bless you. There's no point where there's negative infinity. Negative infinity is a concept, it's an idea, it's not an actual point. So you'll never, ever, ever put infinity on your number line. All we do is put 5. Now, at 5, is it gonna be an open or a closed circle? Open, why? It's not a bracket, it's a parentheses, very good. And then am I gonna shade to the right or to the left?
To the left.
To the left, because it goes from negative infinity to 5, so I want everything smaller than 5. Okay. Can we do one more like that, and then you can try the last two?
Yes.
Letter D, same idea. I actually love interval notation. It tells me which two numbers matter, negative 2 and 3. And then I just ask myself, what is my circle situation? At negative 2, open or closed?
Closed.
Good. At 3, open or closed? Open. No questions? Any questions? What's going on? Everybody cool? All right. And then I like interval notation again because I'm just going to shade in between them. I'm going from negative 2 to 3. I already know what's happening at the ends. Everything else is fair game. So I just shade in between those two. Okay, take a second. Try E and F. Try E and F on your own. E and F on your own. All right. Who can explain E? Ava?
Okay, so 7 would be a closed circle, and you just need 7 because it'd be closed because of the bracket, obviously, and then you would go to the right because of the infinity.
Perfect. That's it. Any questions? Who can explain letter F for me? Yeah, Max.
Oh, okay, so I got negative 3.
Uh-huh. Open or close?
They're both open.
Perfect. And where do I shade? Perfect. Nice. Easy, right? Am I moving too fast or are we doing okay? Awesome. Okay. Now we are going, the next two problems say right as an inequality or right as an interval. So we're essentially going backwards and forwards from what we just had. This is pretty basic once you get the hang of it, but if you haven't seen it before, it might feel a little funny. So this first one's interval notation. I've got 5 and I've got 7. Every time you see two numbers like this, you always write the two numbers and you put X in between them. My symbols are always going to be a less than, but my question to you, is it going to stay a less than or is it going to be a less than or equal to? On the 5, it's a parentheses, so is that a less than or a less than or equal to? Just a less than, very good. It's an open circle, so we just keep it less than. 7 is a bracket, so it's going to be or equal to, closed circle. Because it's implying that we're doing everything between them. This is how we write in between those 2 points. Okay? The next one, let's pretend that's a negative infinity. Since negative infinity is not a point we can graph, we don't need to use it in inequality notation. We can just say X and 3. Do I want numbers smaller than 3 or bigger than 3? I want less than, and do I want less than or equal to or just less than? It's kind of hard to ask that question because I have to say a lot of words to get to what I want. But less than or equal to because I've got a bracket here. Okay, and then last one, what are those two numbers? 6 and a 9. Let's pretend those are both closed circles. What would my symbols in between 6 and X be? Or equal to, good. And what about between X and 9? Same thing, very good. Okay, now we're going backwards and we're going to write these as intervals, and I gave them to as inequalities. Do you feel equipped to try it on your own, or do you want me to walk through the first one? Okay, you got it. Okay. Go. I want you to write these in interval notation. Okay, take a second, finish the one you're on. Okay. We're gonna do number 4, letter A first. Ava?
Okay, so x is greater than 6, you put 6 on first, and then I put infinity, and both just the parentheses, no bracket.
I forgot to say this earlier. You always use a parentheses with infinity. Do you guys know that already?
Yeah.
You might be like, yeah, we knew that. Just wanted to stress it. It's fun to say always in math because I don't usually get to say it. So always a parentheses. Always. Okay. Somebody else help me with theme. Yeah, Max.
I did parentheses 5.
Good.
And then a little comma. And then a 10 with the bracket.
10 with a bracket. Good. Everybody good with Max? Zach?
For number 4, does it matter if you put infinity first or?
Great question. Let's put it second because it says it's greater than, so I want the biggest number to always go second. Great question. Everybody good? Letter C? Mm-hmm.
I did parentheses, negative infinity, and then comma with the -7 bracket.
Very good. Andrew, right? Your name's Andrew. Okay. If you're like, no, just I'm trying to know. I know most of you guys, but every so often I've got to get them out. Okay. Great. Yeah, perfect. I love that we always use parentheses with the infinity, but the 7 was a or equal to, so we had to put a bracket with that one. All right, now I've got some distributive property. This is old hat, right? You guys are good at this. The first one, you're just going to distribute that m throughout. See what we're going to get. So shoot your arrow, distribute m, multiply it by everything. Mn squared minus m times q. Easy. The second one, though, doesn't look like that, though, right? What do I do for this one?
Take out a 3.
Take out a 3 and an x and a y. We're essentially factoring this, so we're going backwards. 3 and x and y is the most common stuff that's in both of those terms. What's left when we take that out? Everyone agree with that?
Yes.
All right. Pretty self-explanatory. All right, now we've got some properties. This is really going to test your Algebra 1 stuff. The hard part about this is you either know it or you don't, and if you don't remember, I'm going to remind you, and then we will know it, okay? So we've got a bunch of different properties. We're just going to come up with them as we go along. The one that's not shown below that is a property is this distributive property, so I may include this in a list like this in the future. So just because it's not included today doesn't mean he doesn't count. Okay, so the first one says 6 times 1 equals 6. Anyone remember what that property is?
Identity.
Identity? What kind of identity?
Multiplicative.
Multiplicative identity, very good. So I'm gonna write multiplicative identity, or I'm just gonna write, I'm personally gonna just write identity. Oh, if I could spell that. Identity. And I'm just gonna put like a little multa behind it to remind me it's multiplication. So identity is anytime we multiply by 1 or we add to 0 so that we literally start with something and end with the same thing. All right, next one, I've got x times y times z equals x times z times y. Billy? It's not inverse. Andrew? Commutative, very good. Commutative. The parentheses want you to think that it's associative, but we didn't reassociate anything. We just flipped the y and the z. So because we flipped those, that's called commutative. All right, letter C. X times y times z equals x times y times z. There's associative. We reassociated. We had some terms together, and then we had new terms together. So that one is my associative. All right, letter D, m plus 0 equals m. I don't call it zero property.
Zero property.
I don't call it that.
Zero property.
She just said she doesn't call it that.
What did we do earlier? We did one just like this earlier. Identity, not of zero. What operation are you doing? Addition. So it's the same idea. We started with something and we ended with the same thing, and the only thing we did was add zero to it. So we're going to call that identity again, but this time it's going to be the additive identity. All right, next I've got 3 times 1/3 equals 1. We've already said this one. Inverse, very good. Can you explain why you would call it inverse, Barrett?
Convert it to a fraction.
We inverted it to be a fraction. When I like teach algebra 1, I always talk about inverse operations, and multiplication and division are inverse operations, so they undo each other. So since I did 3 times 1/3, we are undoing the 3 with the 1/3 and getting back to 0 or to 1, which is my identity. So when your answer is an identity, that means it's an inverse problem. All right, A times B equals B times A. Yeah, Billy. Commutative again, very good. All right, just 2 more identities. 7 plus -7 equals 0.
Would that be the 0?
Say that.
Would that be the 0?
I wouldn't call that one 0 either. I know 0's in it. But what's happening? What are we doing?
Oh.
Opposite. What's another word for opposite?
Reciprocal.
No.
Yes.
Inverse. Who said inverse? Megan. What inverse though am I doing this time? The additive inverse. Very good. And then this last one, what is this? Associative. We'll just call it associative. We don't need to clarify commutative or associative with addition and multiplication. Okay, perfect. This is a nice little brain teaser from the past. All right, flip it over. We're going to do some exponential stuff to close out today. We're going to spend a whole unit on exponential things later on, but we're going to do just a little reminder of some rules. We could go one at a time, all these rules, but we're just kind of going through them as we come up to them in a problem. So this first one, I've got 3 over x squared. Can we simplify 3 over x squared? Nope. We're going to raise it to the third, though. When I raise this whole fraction to the third, everything gets raised to the third. So 3 gets raised to the third, and x squared gets raised to the third. So 3 to the third is 27. And then x squared to the third, 6. Very good. We are going to multiply those when we do power of a power. You don't have to write this in between step, but I personally forget when I haven't done them for a while. So I'm going to write that so I know that I'm going to do x to the 6 because I'm multiplying them. All right. Next one is a very similar idea, but this time we're raising it to the -2nd. You have one of 2 choices of what to do. The first thing you could do is multiply or distribute this -2nd exponent to everything. So we could do 5 to the -2nd, x to the -2nd, 2 to the -2nd, or y to the -2nd. Another thing you could do is just deal with the negative first. What does that negative exponent do?
It's like flip the numerator and the denominator.
It flips my numerator and denominator. Very good. So I could just keep that 2 on the outside and just flip my numerator and denominator and then square everything later. You're going to end up with the same answer, but whatever your approach is fine. Just one of those 2 options. In certain situations, I'll probably do one over the other. In this case, since nothing else is negative, I will probably do the second way where I flip it and then I square everything. But later on in these examples, I'm going to distribute that and then deal with the flipping, okay? So the choice is yours. Just be consistent. So when I square 2, I get 4. When I square y, I get y squared. When I square 5, I get 25. And when I square x, I get x squared. That's the same thing if I did 5 to the -2nd, I would still get 25 on the bottom, et cetera, et cetera. Now, can I simplify this or is this done? It's done.
Yeah.
Does anyone else else ever try and simplify like perfect squares?
Yeah.
When it's like 5 and 25, I'm like, there's got to be something there. There's nothing there. So that's why I like to ask, make sure that we're all good on the same page. And don't feel silly if you thought that too, but I like to always check. Is it simple? Am I done? All right, let's do this one together because I've got another rule coming up. Again, you have a couple choices here. One thing you can do is simplify the entire top and the entire bottom and then cancel when you're all in one fraction. Another option you can do is start canceling. So I've got like this x squared on top and I've got this x to the third on bottom. I can simplify either on top and bottom or on opposite sides of the fraction bar and then combine later. So you have a couple options. I am not going to simplify. I'm just going to do all the top together simply because that helps me do another rule of exponents. If I'm going to simplify the top, I've got 5 times 3, which is just 15. Don't make that harder than it has to be. It's shocking how many times we try and make that different. And then I'm going to do x squared times x. What's that?
X.
Third. So I've got x squared times x. When you're multiplying the bases, you get to add the exponents. So then I've got y and y to the 5th. That becomes y to the 6th. Okay. Then I've got to move to the denominator, and I have 6 times nothing, which is just 6. I've got x to the 3rd times x to the 4th, which is x to the 7th. Don't try and make it 12. And I've got y squared and y to the 3rd, which is y to the 5th. Very good. It's really easy to start kind of combining all of those terms, all those skills all together. All right, now we are going to simplify. I didn't simplify before. Now I'm ready to. 15 and 6. Anything to take out? Yes.
5 and 2. Well, that's what's going to be. Take out a 3.
Take out a 3.
Yeah.
Good. So we get 5 over 2. All right, my x's, what does that become? Ava?
So I got and then the x would go to the bottom.
Okay.
So I got like the y would stay on the side.
I just want to know about the x.
Okay, so the bottom would be like x to the 4.
Good. Remember when we're dividing them, we're going to minus my exponent. So 3 minus 7 is -4. The minute you get a negative exponent, it has to switch sides. In this case, it means go to the denominator. So that's why x to the 4th is in the denominator. Yeah, Max?
So if the 7 and 3 would flip, the x would stay on the top.
Stay on the top. So think about when we're dividing these, the negative automatically makes it go to the bottom. When we are, and we get a positive number, it stays on top. That's like the general rule of thumb. What's my y situation going to be?
Just Y on top.
Just y on top. Good. Can I simplify this anymore, or am I good? Good. Okay. All right, can I be quiet for you to try these next 2 for a second? Okay. Take 1 or 2 minutes, try the next 2. Feel free to turn and talk to a partner if you need to. This is where we can do group work. Is that recycling? And tell me your name again.
Sophia.
Sophia, were you here the other day?
I was here on the first day.
You were here on the first day.
Yeah.
Okay. I haven't seen you guys in a few days. I like forgot everything. Forgot who was in all my classes.
For E, can you solve with the parentheses first and then?
Like you can flip and then do your exponent. All right, are we close to a stopping point? Yes, no, maybe? No, okay, take another minute. All right, now wrap up what you're doing. Okay. Letter D. What I would probably do first is I would see if I can simplify anything. You're welcome to move your numbers if you want, but I'm actually just going to simplify as is. So I've got 3 and 6. I know I can take a 3 out, and I'm left with the 2 in the denominator. I'm going to do my x's, so I'm going to do 5 minus -3. That becomes a positive 8. Where does my x to the 8 go? On the top. I'm going to do my y's next, so -4 minus 5. You do not have to write them off to the side like I am. I'm just trying to prove a point. -4 minus 5 is -9. Where does that go, top or bottom? Bottom. And then z, I've got 8 minus 2 is going to be 6, and that goes top. Very good. So all in one step, I don't have to simplify anymore. That's as good as that's going to get. Anybody questions? Nope. All right, next one. Now this you can do a couple different things. You can simplify or move all the things on the inside before you deal with the exponent. I think I'm just going to distribute that -2 to everything and then deal with moving things. So 4 to the -2, blah, 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 blah. 4 to the -2, x will be to the, what is that, and x going to be on top? What I do, x to the 5th raised to the -2. -10th. Okay, good. Just want to make sure we're good. Y will be to the 6th and z will be to the 16th. Everybody cool so far? Got to do the entire denominator next. That's where we always get lost. 8 to the -2nd, x to the -2nd, y to the 8th, and z to the -4th. All right, this is maybe where I would start switching places. So again, you could just simplify as need be, but because my coefficients are to the negative power, I'm going to switch everything. So anything that's a negative exponent, it's going to switch sides. So I'm going to get x squared or 8 squared on top, as well as x squared, y to the 6th stays on top, and I get z to the 16th and z to the 4th on top. And on the bottom, I get 4 to the 2nd, I get x to the 10th, and I get y to the 8th. Does that look good to you guys? Okay. Now I'm going to simplify. 8 squared is 64. I'm going to do all my x's at the same time. X squared and x to the 10th is going to give me an x to the 8th on the denominator. I guess I can do 4 squared at the same time. I get 16. Then I'm going to do my y's. Y to the 6th over y to the 8th is going to be y squared in the denominator. And then z's, all of that stays on top. I get z to the 20th on top. My last step, though, is I got to do 64 and 16. I can simplify those. The 64 divide evenly into 16? Yeah, to be 4, right? So I can just make it 4 times z to the 20th over x to the 8th y squared. And we cannot simplify that anymore. That's as good as that gets. Anybody questions? For the first one? Is that too far away or can you see it?
Yeah.
Okay. Anybody questions on either of those two? Okay, let's do a little tiny bit of scientific notation. Okay. Remember scientific notation, everything is going to be a number with a decimal. So I'll make this 4.2, and then it's going to be times 10 raised to some power. Depends on how much I had to move the decimal. 1, 2, 3, 4. Is it going to be 10 to the positive 4 or to the negative 4? Positive, good, why? It's not a decimal. I like to think a really big number should have a positive exponent, right? Just whatever makes sense. So now the next one, I've got a really small number. It's going to be 10 to a negative power, and I moved it 1, 2, 3, 4. So that's going to be 10 to the negative 4, 1.6. Now, when I start doing all of these pieces together, I just keep everything kind of in its little lane. I do the actual numbers with the decimals first. I divide those, and then I divide these using my exponent rules. So 3.6 divided by 1.2, that's actually a clean number, isn't it? Isn't that just 3?
Yes.
Yep. Good, and then when I do my exponents, my 10 to the power, I'm dividing them, so I'm gonna do 19 minus -3. That becomes a big positive, which is what, 22? So 3 times 10 to the 22nd. I am gonna throw a 0.0 just so it still looks nice in scientific notation. Okay. Similarly for the next one, again, we're gonna keep in our lane. I'm gonna multiply my 2 decimals together, and then I'm gonna multiply my 2 exponents together. Normally I pull a calculator up on my iPad, but I do not have time, so I'm just gonna do it off to the side on my calculator. Don't be afraid to use yours. 1.5 times 7.6 is 11.4. And then 10 to the 6 times 10 to the 9th, do we add or multiply those? Add, good, to be 15. Am I done?
They gotta move it over.
I gotta move it over 1. So since I move it 1 over to the left, I gotta make that 1 bigger. So 1.14 times 10 to the 16. Okay, we will save E to do at the beginning of next class. One last thing I want to mention before you all start packing up. You guys all know that -4 squared is not the same thing as -4 squared,
Yeah.
correct? Okay. Also, don't move yet because I got to tell you where we're sitting. Your P1 homework is due tomorrow. I see you tomorrow, so make sure you have that done. Let me